Good morning, math scholars. It's a rainy Thursday, so everybody's really tired in here. I think they wanted to keep the lights off so they could take a nap, but not so much. We turn the lights back on. You do need a Pascal's triangle in front of you today because we're going to be filling it out, and then we're going to learn how you can save time, and you wouldn't have to actually FOIL out something that would be a dreadful FOIL. So, for example, let's say I have to FOIL out x plus 4 to the 5th power. Wouldn't that be a dreadful FOIL? You'd have to write x plus 4 5 times. Oh, I'm not going to write it that much. And then you'd have to FOIL them all out. It would take a really, really, really long time. We have a shortcut for you today called the binomial theorem that allows you to get the answer much more quickly. Okay? And who's excited for shortcuts? Yeah! Woo! All right, so let's start with our Pascal's triangle. So the guy that invented this was named Blaise Pascal. He lived from 1623 to 1662. So like we said, he was kind of young when he died, but hey, he made some mathematical contributions while he lived. So all of your edges are going to be ones. And we're not going to fill out the whole entire triangle today. We're only going to do like the first 5 or 6 layers. Everybody's got their earbuds out today. All right, so every entry on your triangle is basically the sum of the 2 entries above it. So like this 2 is coming from 1 plus 1. So what would be in my first empty box here? 4, because 4 is the sum of 1 plus 3. Okay, this box here would be a 5, because 5 is the sum of 1 and 4. 10 would be in this box here. What would be in this box here? So every layer is kind of like symmetric. 1, 5, 10, 10, 5, 1. What would be in this box here? This box? This box? This box? And so you see the symmetry, 1, 6, 15, 20, 15, 6, 1. Do the next layer all by yourself, and then we'll stop. We do not need to go beyond the 7th layer. This is not homework. This is part of our notes. Your homework is out of the book. 7, 22, 35, 35. Oh, my bad. 21, 21. I was trying to think of why you said rascal flats when you pointed to the homework. That's what I was distracted. We are live on the internet right now. Okay. Alright, now that our triangle's filled out, we're going to see how it can be used to do FOILing problems. So I do want you to label your layers. Your first layer is called the 0 layer. 0th layer. And then the second layer is actually called the first layer. So it goes 0th, 1st, 2nd, 3rd, 4th, 5th. I don't think we ever use the 6th layer today, so that's good news for us. Basically, you'll use whatever layer is the exponent that is on your problem. So if you're taking a binomial, and you're taking that binomial to the 0 power, you look at the 0 layer. So the 0 layer is 1. Then that would just be your answer for that one, because anything to the 0 power is 1. Make sense? All right, to take a binomial to the 1st power, you would refer to the 1st layer. That would be this one right here. These numbers here stand for the coefficients of the 2 terms in our answer. So we'll have a 2-term answer. Both of them will have coefficients of 1. I can put a plus in between because I'm doing a sum right now. When I do a difference, it's a difference. Now here's how it works. In the first term, you take the first term here and you place it here to the 1st power. It's just x to the 1st power. In the second term, you'll take your second term here, the y, and you put in there. And that one is really easy because x plus y to the 1st is obviously x plus y. It gets a little bit cooler when you get to save time and you're cubing and 4thing and 5thing powers. Alright, let's get to the squared one. So for the squared one, we'll use the numbers in the second layer as our coefficients. So our coefficients will be 1, 2, and 1. And I write them out and I leave a lot of blank space because that's when we put the stuff in. Alright, so start with our first term. Our first term is x. He will go with the 1, and he will go to the 2nd power. Whatever power you see here is the power you will put with the x. Now every term you go down one term, you go down 1 degree. So if this is x squared, this would be x to the first, and this would be x to the 0, which I'm not even going to write, because x to the 0 equals 1. Okay. Now the y we do in reverse. We do a y squared, but we put it in the term on the farthest right. Then as we work back a term to the left, that's when the y loses a degree. And then as I go back, then it'd be y to the 0. And that's it. Now all those y to the first and stuff, I actually probably wouldn't realistically write that. This is probably how I'd write my answer. But I want to prove to you that the Pascal triangle trick actually works. It's called binomial theorem. So I'm going to actually FOIL this out just to prove that FOIL would yield the same result. So you can just watch. You don't have to do this with me. X times x is x squared. X times y is xy. Y times x is xy. And y times y is y squared. If I add to my like terms, wouldn't I get that result? Awesome! That binomial theorem is great. Okay? Did you follow? Isn't it weird? We'll do like a million more today, so you'll get a better feel for it. Maybe not a million, but at least 4. Let's try this one. 95. Checking that we're still recording. Sweet. Okay. What layer are we going to use? We're doing to the 3rd power. 3rd layer. So this was the 0 layer, layer 1, layer 2, layer 3. So the 1, 3, 3, and 1 are my coefficients that I'll write out, and I want to leave a lot of spots because that's where x's and y's are going to be going. So let's start with our x's. We will start with an x to the 3rd in our leftmost term. Every term we go from here, x will lose 1 degree. So this one would be x squared. This one would be x to the 1st, and this one is x to the 0 power, which I don't write. And I probably realistically wouldn't write that one there. Okay, let's try our y's. Our y's are going to start in the left term, or sorry, the rightmost term, and it's going to be y to the 3rd. Every term I travel to the left, it will lose 1 degree. So y squared, y to the 1st, and y to the 0 power. Okay. 1x and 2y. You can absolutely use this trick, but this 2y will work as a unit. We'll do on it that way. The 2 will actually get squared too. And the 4 and cubed and stuff. Yep. Okay. And I think I kind of lost my train of thought. I think we're pretty much done. One plus in here. If you really want to erase unnecessary ones, you don't absolutely need this one. I erased more than I wanted to. You don't absolutely need this one out front either. That's it. So you just saved a ton of time because foiling out 3 binomials would take a lot of foil. Yeah. If there's a subtraction sign in the beginning problem, these signs will alternate. You'll go from positive to negative to positive to negative to positive to negative. We'll look at one like that today too. You guys are asking great questions. You're like, you're already knowing where we're headed with this. All right, we're just going to do one that's one more layer down. This time we're using our 4th layer. So our numbers are 1, 4, 6, 4, and 1. It's like your starting point. That's your base, your coefficients. Yeah, so I've got the layers you would need up on my board, so you can have it. But generating it yourself should be so easy. You just start with a 1 and just go down from there. It's the sum of the previous 2. Okay, so we're going to go with x to the 4th to start, and then every term, x will lose 1 degree, so we don't have any x's at all in that last term. How are you going to do your y's? Start on the far right with the y to the 4th, and just lose 1 degree as you travel to the left until you don't have any y's at all. That's your answer. Alright, so we're going to do some now with actual numbers in them and not just x's and y's, okay, to see how that would work. You will probably want your calculator, the numbers start getting a little bit big because you end up doing like 5 cubed and 4 to the third and, you know, stuff like that. Here we are. We're going to do our first binomial cube problem where the binomial actually has some numbers in it, not just x's and y's. So I guess the first question is, what layer will I be using to write out my coefficients? Circled layer. It would be this layer here with all the threes. So basically, if it's a cube, pick the layer with all the threes. If it's a fourth, pick the layer with all the fours. Okay. So it's 1, 3, 3, and 1. Our x's are going to be easy because they're just going to be like how they were previous. X cubed, x squared, x to the first, no x at all. X to the first, x to the first, x. Now here's where it's going to be a little bit different. Instead of having a y that I'll be doing, I'll be using a 4 because my second term is a 4. So you're going to start down here. I'll use blue. This would be 4 to the third. And as I work left, my 4 will lose a degree. So this will be 4 squared. This will be times 4 to the first. And there'll be no 4 here. So now we do have a little bit of work. We're not done. We do have to simplify each term. So that's where I said the calculator will come in handy to calculate these numbers if they get large. My first term looks fine. It's just an x cubed. But my second term, I would want to take that 3 and the 4 and multiply them together. So what would that be? 12x squared. In my next term, I would want to take that 3 and multiply it by 4 squared. What's that going to be? Good. And in my last term, I would want to calculate out what 4 cubed is. 64. And that's your answer. Awesome. Saving so much time not having to FOIL that. It does not, so using the binomial theorem does not get harder. The numbers just get a little bit bigger. You'll have something like 2x plus 5y. That would complicate it more. You know, but the concept remains the same. You use the layer to get you started, you know. So this is just a quick discussion about what happens if there's a minus. It says to expand the power of a binomial difference, you can rewrite the binomial as a sum. The resulting expansion will have terms whose signs would alternate between plus and minus. So what they mean by that is if we're doing y minus 3, you can write it as plus negative 3, and then just use the negative 3 as the guy that you're cubing and squaring and stuff like that. Okay. Go ahead and jot that one down. Alright, what layer are we going to use? The layer with the 4s in it. So 1, 4, 6, 4, and 1. We'll do our y's first. Y to the 4th, y to the 3rd, y squared, and y to the 1st. Alright, so we're using a negative 3 as our guide. We'll start over here on our far right. It'll be negative 3 to the 4th power. And anytime you take a negative to the 4th power, what happens? It turns positive, so just keep that in mind. There will be a plus sign here because this will be a positive term. Okay? These will alternate. So if once I've established this to be a positive, I know this will be a negative, this will be a positive, and this will be a negative. Just kind of do that immediately. Okay, so this term here would be negative 3 to the 3rd. You might as well just do it as a 3. So we've already taken care of it. It will be negative. This term will be, I'll just write it with a 3. 3 squared. It will turn positive. This will be 3 to the 1st. And there's no 3 in my first term. My first term's done. It's y to the 4th. My second term, I'll have to multiply the 4 and the 3. It'll be a 12. My third term will be a 6 times 3 squared, so 6 times 9 is at 54. My next term is 4 times 3 cubed, so that's 4 times 27. I need your help on that one. 4 times 27. 108. 108. And then my last term, 81. And you just want to make sure you're alternating your signs. Negative, positive, negative, positive, positive. Yeah, so once I figured out my pattern, I just kind of used a +3 in my calculations to make life a little simpler. They will always, always alternate. How are we feeling? Do you want to do one more? Make it a real hard one, and then we can call it a day? Okay. I'll just pause it and give you a couple of seconds to look, okay? Alrighty, this will be our last one. We have a minus sign and we have a number with the y, so up in the difficulty a little bit. If you want to write it as a sum, you can, but keep in mind it's a -2y that we'll be using in our calculations. What layer would I want to use? The one with the 3's in it, so this one right here, like circling it. So 1, 3, 3, 1. And we're so used to our variable being first and just plopping our x in. So this is slightly different. 5 is kind of taking our place of our traditional x. So we will simply do a 5 cubed right here instead of an x cubed like we've been doing all day. A 5 squared here and a 5 cubed. And no 5 on the last term. Okay, we're going to start on the far right and we're going to use a -2y with our calculation. So it'll be a -2y cubed. That becomes problematic for a lot of people because you actually have to cube the 2 and the y. Alright, what is -2 cubed? No, it's -8. Oh. -2 times -2 times -2 is -8. So you know what that means, right? That this term will be negative, which will make this term a positive, which will make this term a negative. So I can put my signs in right now if I want to, because they alternate. So it's going to go negative, positive, negative, positive. And now I can just work, now that I have my signs figured out, I can just work with a 2y. So this one would be a 2y squared. It is still important that I use parentheses, even though I ditched the negative sign, because the 2 will need to square, and the y will need to square. Okay. And then this is just 2y to the first, so I don't really need my parentheses. Alright, we have a lot of stuff to simplify. This looks like a simplifying mess. How are we doing? Am I going too fast? We're doing good? What is 1 times 5 to the third? 125. What is 3 times 5 squared times 2? Is it 150? What is 3 times 5 times 2 squared? 2 squared is 4, by the way. I think it's 16. Yeah. And then the y gets squared. Yeah, so the y's going to work in reverse. Y cubed, y squared, y, and no y. I kind of just check that my degrees go in order when I'm done. And I'm just checking that, do my signs alternate? Yes, negative, positive, negative. So I think we're good. Awesome. So these take a while. There's so much simplifying and stuff. So the homework's really, really short. I'll pull it up so that people on the internet can see it. It's page 383, 21, and 24 to 27. Did anybody need me to go back so you could finish writing this one down? Anybody in the class? No? All right. Well, thanks for watching the video at home. Hopefully you have a happy, happy day.